Welcome to part 4 of the Intro to Polar and preparing for the free response question. Now, this lesson will be going into more polar graphs by hand just for more practice and doing the polar graphs on a calculator, on a graphing calculator, and getting used to the mode function on the calculator. Now, let's take this function right here. R of theta is equal to 2 plus 2 cosine theta. And let's practice graphing it by hand. So, once again, with polar graphs, we're going to draw circles because we are rotating, and these circles will represent the radius. Okay, and last one. Okay, now let's make a table of values to see where the points are going to be. So let's take theta equals 0. That's going to be 4. And let's take theta equals pi over 3, an easy one. Cosine will be 1/2, so that will be 3. Cosine of pi over 2 is going to be 0, so that'll just be 2. 2 pi over 3, that's going to be -1. So 2 plus -1 is just going to be 1. Now, cosine of pi is going to be -1. 2 minus 2 is going to be 0. 4 pi over 3. We're going to get 1. 3 pi over 2. That's going to be 2. And back to 2 pi. 2 pi is going to be 4. Because cosine of 2 pi is 1, and we'll get 4. So let's graph this. So again, a huge concept is polar graphs, we're rotating. And unlike the rectangular coordinates, we're going to be rotating in polar along the radii. So let's start from theta equals 0, and I'll write the angles here. Pi, 3 pi over 2. And comma 2 pi. Okay. Now, 0 is going to start right at 4. Right here. Then pi over 3 is going to be a radius 3 here. So it's going to be somewhere around here. Okay. Pi over 2. This angle right here. And radius is going to be 2. 2 pi over 3, so around here, our radius is going to be 1. And at pi, our radius is going to be 0. Now, at 4 pi over 3, our radius is going to go back to 2. Around here. 3 pi over 2. It's going to go to 1. It's going to go to 1. And this angle, 3 pi over 2, is going to go to 2. Right out here. Yes, around here. And then 2 pi is going to come all the way back to 4, where we started. So again, if we graph this, we're going to be rotating. So let's start here. Start from 0, the angle 0. And we're going to be rotating this way to this point, come down, come to 0, the origin, and then we're going to come out and rotate back. Now, once again, this shape happened all through rotation, and you have to keep track of which theta value represents each point. And now this graph in particular forms a cardioid, or the shape of a heart. And the different types of polar graphs are significant, but unfortunately we won't be able to get to them in these lessons. However, if you are to graph any polar graph that you get by hand, you should get its shape. Now, in the graphing calculator, the way to graph this is setting the calculator to polar mode. So you would click on the mode button, and then you'd go to polar. it says right across from function. You'd click on polar. So write that down. So you'd click mode, polar. And now your x values are going to be in terms of theta, and your y values are going to be in terms of r. So you're going to hit the y equals button, and then put in 2 plus 2 cosine of theta. And when you graph it, you can actually see the rotation occurring in the graph. So you'll be able to see it start from this point here, rotate all the way to all the way across the pi over 2 angle to 0, across, and then back to its original starting point. And you would know that, and then you would also know that the domain of this particular function would be from 0 to 2 pi, because that is the those are the angles that make the shape once instead of rotating an infinite amount of times. So once again, graphing calculator, you go to the polar function, y equals, and you're able to graph that way.